Hello and welcome to my video today. I have a new product in from Hansshow. This is a 12-volt inverter, and what it does is it provides conversion from 12 volts to 120 volts for use on 2 outlets on the device. It also has a USB hub on the side with 2 regular USB-A connections, a high-powered USB-A, as well as a high-powered USB-C. So I'll be unboxing and testing this out today on both my Tesla Model 3 and my Fisker Ocean. So let's get started. So here we have the box. It says 200 watt power inverter with QC 3.0 and PD 3.1 fast charger. This one is specified for North America with 110 volts, really 120 volts. And let's see what else we have on here. On the back, converts 12 volt DC to AC power, 4 USB ports, and I'll go over this in detail when I take the unit out of the box. Has short circuit overload, high voltage, low voltage, high temperature protection. The input voltage of the inverter is DC 12 volts. It can be only used with a 12 volt car. Please ensure that the maximum power of the equipment does not exceed 200 watts. I have more detail on this when I do some testing. The temperature rise and fan noise are normal during use of this product. Do not block the vent when using, and do not insert foreign matters into the vent. Keep children away from the product, and keep the product dry and avoid liquid entering. On top, we have an instruction guide here with details. Here is the inverter itself. We have the 12 volt connector that gets inserted to that power outlet and a decent length cord. I'll be measuring that. And here on top, we see 2 NEMA 515 outlets. We have an on and off switch and an LCD display. On the side, we have the USB-A 1.1 amps, another USB-A 2.0 amps. We have a USB-A quick charge 3.0, and we have a USB-C with the PD 30 watts. And on the back, we have some more details. And by the cable, we have the vent with the fan that I mentioned earlier. So you don't want to block that. We also have additional vents on the sides for cooling. Overall, it's pretty compact. As you can see, it's about 6 inches long, or about 15.5 centimeters, about 2.5 inches wide, or about 6 3/4 centimeters, just under 1.5 inches deep, or about 3.5 centimeters. Let's take the cord out of the Velcro here, and let's measure that. All right, so we have 20 inches, or about 51 centimeters in total length for the cable. Now, this product is designed for Tesla products, specifically the Tesla Model 3, but it could be also used in other vehicles. I also have a Fisker Ocean, which I'm going to be testing it with as well. It's best to check your vehicle for specific restrictions on power usage. For example, on the Tesla Model 3, the 12 volt outlet provides 12 amps of continuous draw, 16 amps peak. So that is 144 watts continuous or 192 watts peak. For the Fisker Ocean, the 12 volt outlet is 10 amps continuous or 15 amps peak. So that's 120 watts continuous or 180 watts peak. So you don't want to go over those amounts since those are the fuse limits, and you don't want to blow the fuse or circuit breaker in Tesla's case. As far as maximum amps go, the two USB-A here are obvious, 1.1 and 2.0. The quick charge has variable voltage and amperage. You have the ability to use 5 volts at 3.4 amps, 9 volts at 2 amps, or 12 volts at 1.5 amps. And for the PD quick charge port, that gives you 5 volts at 3 amps, 9 volts at 2 amps, or 12 volts at 2.5 amps, which gives the maximum amount of 30 watts. As far as the NEMA outlets go, a NEMA 515 is a 15 amp outlet, but you do not go over 12 amps because that is the restriction of the 80% rule. However, since this is going to be connected to the car's 12 volt outlet, you're going to get nowhere near the 12 amps that you would get from a regular wall socket. So for the Model 3, I would suggest not going over 1.2 amps, and for the Ocean, not over 1 amp for these outlets. So let's go out to the car and check it out. Here we are in the trunk of the Fisker Ocean. We have the panel back here with the 12 volt outlet. Obviously, the Fisker Ocean is a little bit more flexible than the Tesla since we already have a 120 volt outlet right here. So if you do need some high powered devices, I suggest using this first since this has a much higher max wattage rating of 1600 versus 200 for this. But the nice thing about this is you could relocate this up to the front of the car by using an extension cord. So if you want to leave this under the front passenger seat, that would work nicely. So if you have some devices that need 120 volts, you can supply them right there. So let's plug it in, and here is the screen voltage showing right here. Here's a close-up look of when I press the power button here to turn on the two outlets. You'll see this LED also turn on. And when this is turned on, the fan automatically also turns on. I'm going to be testing with a couple of different devices. One is a iPhone 12 and another is a Samsung Android phone. So I'm going to be testing both those out. First thing I'm going to connect to is the 1.1 amp port right here. So let me plug a tester in. As we can see, not connected to anything. It's providing 5 volts. So I connected the Lightning to the iPhone, and we can see that we're getting 0.98 amps, which is just around what we would expect for the limitations on this first port. Let's take this one out and go to the next one, and the next port has 2.0 amps. So let's see how that works. I'm still seeing it at 1 amps here, so not sure if it makes any difference with the cable, but I'm going to try all the ports and see what we get before I test the next item. And certain devices are going to be limited to around 1 amps anyway, due to either the device or the cable being connected. So that's all we get for the iPhone. So I'm going to disconnect this, and now I'm going to look at my Android phone. I'm also going to attach the USB-C here, and I'm going to do the same thing as I did with the iPhone. I'm going to connect it, and we're actually getting a little bit more amperage on here. I'm seeing 1.49, 1.5 from that port. So very interesting. So the top port, I'm getting 1.5 amps. Let's remove that. And let's plug it in. And I'm getting a little bit more. As you can see, I'm getting 1.7 amps, so it is a little bit higher than the other port. And let's try the next one. Interesting. So the QC port is using higher voltage. We're getting roughly around 9 volts and about 1 to 1.1 amps. So we're getting a little bit more than we did with that USB-A with the 2 amp port. It's probably just a limitation on the cable and the phone. It's going to vary on what your phone supports. So let me disconnect that. So now I am going to attach to the last one that PD 30 watt, and I am going to put my tester in there, the cable. All right, so as you can see here, it is using 9.4 volts and 1.2 something amps. So that's getting us about 11 watts out of this compared to about 9 on the other port, so a little bit higher. Now let me test the iPhone. So I'm going to connect USB-C here. And we're seeing 9 volts and 1.58 or 1.6 amps here. So definitely some extra power using this port compared to the others. So let's test the iPhone 16 Pro Max with all of these ports. I'm going to plug into the first one. And as expected, we're seeing 5 volts. We were expecting 1.1 amps, but we're actually seeing anywhere from 1.2 to 1.4. So it is kind of going up and down. Let's disconnect. I'm going to put it in the next USB-A port. Also 5 volts. And it should support up to 2 amps. Let's see what we get. All right, so roughly similar performance as the first port. Let's disconnect that, and now we're going to go down to the next, the QC 3.0 port. It is showing 5 volts. Let's connect that to the phone. So depending on your phone and the cables connected, you may not get that quick charge speed of 3 amps. In this case, I'm seeing the same as we got with the other 2 ports. Let's disconnect. And now I'm going to try the last one, which is the PD 30 watt. Next, we're going to connect the tester to that port and connect the USB-C. And now connect that into the phone. We're now seeing 12 volts, starting at half an amp, but it looks like it is increasing. So the voltage is at 11.9, and the amperage seems to oscillate between 1.2 to 1.3. So we're seeing somewhere between 14 and 15 watts provided by this connector. Now what happens if we do multiple devices here? I'm going to connect the Android to the 2.0 port, and we're still charging fine. I don't see any difference with the quick charge port. Let's disconnect that one and go down to the... So I don't see any difference between connecting 2 devices here on the USB 2 amp and also the PD port at the same time. So let's connect the Android here, and as well, this is also charging on the QC port and the PD port at the same time. No difference in charging rates for the tester here, so everything seems to be working fine. And if I want to charge 3 at a time, so I'm not seeing any change in the amperage or voltage on the tester. So 3 devices connected at the same time seems to be no problem. At this point, I'm going to be testing the NEMA 515 outlet. I'm going to put in a tester here, and I am going to hit the power button here to turn it on so we can see what we got here. Let's look at the different functions. Let's look at voltage. I'm showing 110.6. Nothing's connected. Amps, 0. Let's keep the voltage on. I am going to connect my laptop and let's plug it in so we can see the info. We're at just under 112 volts, or around 112 volts right here. Let's click on this. We have 0.4 amps that it's providing. Yep, so that is pretty good. So we're seeing close to the max that this can provide. So we're at just around 40 watts that is coming out from this outlet. So definitely not a problem if you're using this with the car. It should easily support this amount. Now there probably will be a limit to how much you could put on here, but this should support 60 and 90 watt power supplies for laptops. So let's connect that quick charge port here. So we're still pulling that 41 watts onto the laptop, and also it is providing 12 volts and 1.1 to 1.2 for the phone. So you can use the USB and the NEMA plugs at the same time. Of course, you're going to want to be wary of the limits of how much amperage that your fuse is capable of. Well, that's about it for the Fisker Ocean. Now I'm in the Tesla Model 3. I'm in the driver's seat. Here is the storage bin here, and you can see the 12-volt power outlet right here. So I am going to open that up and insert the plug. And now we have power to the unit. As you can see, 14.3 volts. I'm going to be doing all the tests that I did previously, except I am going to do it super fast and just show you the results for all of them. First, we're going to do the iPhone 12. Next, we're going to do the Samsung Android phone. And now for the iPhone 16 Pro Max. So let's try the laptop. I'm going to plug in the tester here, turn the power on. Should see 111.3 volts. Let's get the power to the laptop. And here we go. Let's press. Now we see the amps around 0.43 to 0.44. And we're putting out about 41.4 watts total. And as before, let me connect some other devices. Let's put in the Android phone. So that is charging. And we can still see the wattage remains the same. Let's plug in the iPhone. And that one is charging as well. So it's hovering around that 39 to 40 watts. Here's the voltage and the amps. So there we go. Well, that about does it for the video today. I hope you enjoyed it and found it useful. If you're interested in purchasing the Hansshow 12-volt inverter, please see the link in the video description. Don't forget to use code RANGER for a discount. If you have any questions or comments, please leave them down below. Thanks for watching, and I'll see you in the next video.